Finding and eliminating software security vulnerabilities is both time-consuming and expensive. Patrice Godefroid, a partner researcher at Microsoft Research, has been working on investigating how advanced program analysis techniques can help find more security bugs effectively. Fuzzing is one such technique which is at the heart of his research.
So fuzzing means automatic test generation and execution with the goal of finding security vulnerabilities. Fuzzing is synonymous with security testing.
Other than fuzzing, there are two other main ways to find security vulnerabilities.
The first one is static program analysis. So a static program analysis tool will read the code of the software and then try to find security bugs in it. Static analysis is fast and it's automatic, but it's not guaranteed to find all the bugs, and it also can report false alarms. The second main way of finding security vulnerabilities in software is pen testing or penetration testing, which is a fancy word for essentially saying manual code inspection with a specific security focus. So in pen testing, security experts review the code, but also the architecture and design of a software application with the goal of finding security vulnerabilities.
So how does fuzzing differ from the other methods? And is there one that should be used over the other?
Like static program analysis, it is automatic. Unlike static analysis, it's more expensive, it's computationally expensive because it needs to run the software. But the advantage is it doesn't return false alarms. So in practice, all three techniques, static program analysis, pen testing, and fuzzing, are complementary. And I would recommend to use all three. At Microsoft, we do.
In his research, Godefroid focuses on the three main core fuzzing techniques: black box fuzzing, grammar-based fuzzing, and white box fuzzing.
Black box fuzzing is the oldest and simplest form of fuzzing. It's very simple conceptually. You take a program and a well-formed input, and then you randomly modify it a little bit, so you fuzz it. And then you run the program with that modified input, and you hope to trigger a security vulnerability. The second main technique for fuzzing is so-called grammar-based fuzzing. In grammar-based fuzzing, the user provides a grammar that represents the input format of the application being tested, and then that grammar is taken by a grammar-based fuzzer and then generate tests. So this approach is very powerful because the user can guide the search towards some specific patterns. The third main way of doing fuzzing is white box fuzzing, which leverages techniques from program analysis and specifically dynamic symbolic execution, constraint generation, and constraint solving. And the advantage of white box fuzzing is that every new test generated will, in principle, cover a new execution path in the program. And so white box fuzzing provides better code coverage and can find more bugs than typically black box fuzzing. If you develop software that can take untrusted data as input, you should use fuzzing. You will find bugs that you didn't know existed before in your software application. I guarantee it. How do I know? We've done this hundreds of times, and each time we find new bugs. You should do fuzzing.
Learn more in Fuzzing, Hack, Art, and Science, a review article in the February 2020 Communications of the ACM.